Alright, so we already went over the derivative of basically every function you can possibly need. We went over logs, exponentials, powers, we went over how to use product rule, quotient rule, chain rule, and we also went over trig functions, right? So now we're going to do inverse trig functions. And we're going to start with the basic one. Let's take the derivative of arcsine, also known as inverse sine of x. This right here, it looks kind of difficult, but I already mentioned a strategy that we could use in the video where I took the derivative of e to the x, and that is call this function on the inside, maybe just f of x, right? Name it something else. And then take the inverse function on both sides, right? So in our e to the x video, what we did was we took the natural log on both sides, because on the right-hand side, that would cancel to be an x. And we already know how to differentiate natural log. In this video, the inverse of inverse sine is just sine, right? So if we take sine on both sides, then this implies that on the left-hand side, you have sine of f of x. On the right-hand side, the sine and the arcsine are going to cancel, and that's going to leave us with whatever is left on the inside, which is just an x. So now we know how to differentiate everything, right? We know the derivative of sine, we know the derivative of x, and we know how to use chain rule, because this is a function inside of another function. And to make that more clear, I can do that, but it doesn't matter. So let's take the derivative on both sides. On the left-hand side, the derivative of sine is just simply cosine. So I'm going to take the derivative of the outside function and then keep the inside function the same. And then we have to multiply by the derivative of the inside function. So now we have f prime of x, and we'd like to isolate that, right? This right here, we're trying to take the derivative of inverse sine. That's the same thing as just taking the derivative of f of x and finding out what that is. So in a second, we're going to have to isolate this guy and then rewrite it in terms of inverse sine. Well, yeah, we'll see how it goes. And then on the right-hand side, you also have to differentiate with respect to x, just 1. Okay, now you have to isolate this guy right here, f prime of x, right? So to do that, we just divide both sides by this thing right here. So on the left-hand side, you have f prime of x equals, on the right-hand side, you have 1 over cosine of f of x. Now, it seems like we're done, right? We have all of this already. Well, not really, because this is still in terms of f of x. Now, you could rewrite it in terms of inverse sine of x, and that's what we're going to do. But you can keep simplifying further. So on the inside, I'm going to replace this with inverse sine of x. So it may seem like, oh, it's done. It's just 1 over cosine of inverse sine. But you can simplify this even more. And here's how. So first, I want to square and take the square root of this cosine. Basically, okay, first, if I want to roadmap it out, what I'm trying to do is rewrite it so that I have sine of inverse sine. So that way I can cancel the two, right? Here's how I'm going to do it. I'm going to take the square root of this on the inside, but also square it. So I now have cosine squared of inverse sine of x, right? And you can see that the square and the square root cancel out to give us what we had before, so it's okay. Cosine squared of anything, cosine squared of, say, x is just 1 minus sine squared of x. So you can see where I got the sine from, right? This is where I'm trying to pull the sine out. Well, so yeah, let's go ahead and rewrite it. 1 over, and then in the square root, we rewrite as 1 minus sine squared of x. 1 minus sine squared of x, except x is whatever's in here, meaning x is inverse sine of x. Okay. So that's how that works. And now, because you have sine of inverse sine, it'll cancel. In case that's not really clear, here's how we're going to think about it. Sine squared of anything is just you can just raise everything to the second power, right? It's the same thing as just squaring the sine. So on the inside, here's what's really going on. This right here is equal to that right there. Because this sine, the square, it doesn't matter if it's here or it's on the very outside, it means the same thing. You're just squaring this function. That's what's going on. So this sine and its inverse sine cancel out, and that leaves you with this x on the inside squared. So this whole thing is just equal to x squared. So you have 1 over root of 1 minus x squared. That's how you do it, right? That's what f prime of x is equal to. And that is the derivative of arc sine. Okay, well, I'm not going to just do this today, right? Because that is actually relatively simple, right? We have this strat down. What about inverse cosine? So now, let's take the derivative of inverse cosine. Now, you're going to find that you can also do it this way, right? Call inverse cosine f of x. Take cosine on both sides, you get something that looks like this, and then differentiate and then isolate this, and then rewrite everything so that it's in terms of cosine of, f of x, or cosine of inverse cosine of x. It's the same exact thing. So I'm not going to do it again this way. Instead, recall this identity right here. Recall that if you add up the inverse sine function and the inverse cosine function, you just get pi over 2, right? This is an identity, that's for sure. And where does this come from? Well, it comes from the cofunction identity, right? That we already used. So if you remember, we had cosine, say, of pi over 2 minus x being equal to sine x. If we replaced x with, say, inverse sine of y, right? Then this would, on the left-hand side, become cosine of pi over 2 minus inverse sine of y. On the right-hand side, you would have sine, but remember, we replaced this x with inverse sine of y. So it's going to look like that. And then next, all you have to do, on the right-hand side, first of all, these guys cancel, so you're left with the y. And all you have to do now is take the inverse cosine on both sides. So now, you have pi over 2 minus arc sine of y on the left-hand side. Because once you take the inverse cosine, this guy cancels out, right? So you're left with whatever's on the inside. On the right-hand side, you just have this y left. So when you take the inverse cosine, it's going to look like this. Like that. So now, to get to this form right here, all we have to do is add inverse sine of y on both sides. So now you have inverse sine of y plus inverse cosine of y being equal to pi over 2. So that's the inverse cofunction identity. Think of it like that. Okay, well, so that's where it came from. And in the future, if I use it, which I am, because I still need to take the derivative of inverse tangent, inverse cotangent, just remember that I explained where that came from here, right? We can go ahead and rewrite inverse cosine in terms of inverse sine, right? And because we already know how to take the derivative of inverse sine, well, then we know how to take the derivative of inverse cosine. So, to isolate the inverse cosine, we just subtract inverse sine on both sides. So we have this being equal to pi over 2 minus arc sine of x. So we can go ahead and replace whatever's on the inside here with that. So this is equal to the derivative of, we replace cosine with pi over 2 minus sine inverse x. Okay, now we can differentiate. Differentiating this first term, it just goes to 0 because it's a constant, right? And then differentiating the second term, there's a negative sign, and then we can differentiate the meat of the problem, the inverse sine of x, which is just that. So you just get 1 over root of 1 minus x squared. This is the derivative of inverse cosine, and this is the derivative of inverse sine. Okay, well, here's the thing. They're negatives of each other, right? That's why I said it would be boring if we just did that, because all you're going to get is just a negative version of this. And that's going to be true from now on. Say we had inverse tangent. We're taking the derivative of inverse tangent. Well, the derivative of inverse cotangent is just going to be the negative version of that. So keep that in mind. Although I'm going to go over it again, of course, in the future videos. Well, that's why. It's because of this right here. We can always rewrite it using that.